Hey guys, welcome to Pep Coding. Today we are going to learn how to solve a Sudoku using bit manipulation. So basically here we would be having a Sudoku. It's a 9 cross 9 Sudoku. So see the blue lines, the blue borders, what do they represent? These blue borders represent about the grids. See, this is grid number 1, grid number 2, grid number 3, then grid number 4, grid number 5, grid number 6, grid number 7, grid number 8 and grid number 9. Okay, these are 9 grids, and there are, let me use another color, there are similarly 9 rows and 9 columns. 1 2 3 4 5 6 7 8 9. Similarly here 1 2 3 4 5 6 7 8 9. Okay, now let's see this, that in Sudoku no number, this number, whatever the number I am adding here, should not be in my particular row, my particular column and my particular grid. Okay, only then that number could exist. So what I'll do here is basically I'll create few arrays, three arrays. We need to check three things: that the number is present in the row or not, if it is present in the column or not, or if it is present in my, see here, 3 4 5 6 7 8. Yeah, this is for my row. We'll take it here. Okay, similarly here should be 9 columns also. Okay, so if I'm checking for this word and one more grid, a 3 cross 3 grid. So my particular number, if I take this number, if I'm adding something, a number here, it should not be in this. So there would be some numbers. Guys, we know that a number could be represented in its bit binary form also. So for binary form, if the bit is 0, suppose we take 9 bits, 1 2 3 4 5 6 7 8 9. Suppose I want to check for 4. So 1 2 3 4. So if here I have 1, that means that 4 is already present there. Okay, so here I'll check if I'm going to add 4 here. So this particular column, do I have 4 or not? At this particular row, do I have 4 or not? At this particular grid, do I have 4 or not? So for these, I'll check that do I have or not. Okay, so how will I check this? Earlier when we were doing this question, we were using arrays. In arrays, 2D arrays, what we were doing is basically storing all the 9 numbers, but here one number which have 32 bits can be used. Its last 9 bits would be used as 1 to 9, and we'll on them and off them. Okay, if they are on, that means we cannot place the number there. If they are off, that means we can place the number there. So it's easy, guys. Let's see how we are going to do this. Let's come to the code. I'll explain you the question more. Guys, we have already done this question in recursion. If you have not seen that video, please go and watch. It would be much easier for you to understand this, because I am doing it in a quite faster pace. So first let's check if, see, if my, this condition is to be here, if my row of I is, first of all let's check when do we need to do the recursion call. If my array of ij is not equal to 0, then what? Then I don't even need to make the calls. Why? because if it is not 0, that means the number is already there. If it's 0, then only I'll add the number. No? If it is already non-zero number, that means that I need to simply pass. See, if it is already 0, we need to pass. So we'll recursively call this function. So array would be as it is, rows would be as it is, calls would be as it is, grid would be as it is. Now what about I and j? See, if I am at the last, let's see here. If I am here at the last place, if I am at the last place, at the last column, at the last cell of my row, in that case, I need to move here in the next row. Else, I need to simply traverse. The I would be same and j would be changed. If I am here, suppose if I am not here, I am somewhere here. So I simply move to here. But if I am at the end, then I need to move to this row at this cell. Okay. So we'll simply put this here. So j less than 8. Why 8 not 9? Because we have a 9 cross 9 and at 8th index is the last index. If it is at the last index, then also we don't need to work. So if this condition is true, I'll pass simply I, else I'll pass I plus 1. Okay, similarly for j also, if this condition is true, I'll pass j plus 1, else I'll pass 0. Okay, now what? Else we need to work. So what should be the work? First we'll check that we'll run a for loop from where 1 to 9. Okay, let's use nums instead of i's. So I less nums less than equals. We are so habitual of using I and j. 9. We are using nums because we are adding numbers, so it is easier to remember. I and j can be confusing. So nums plus plus. So guys, what should be the condition before I proceed further? So my condition should be that the num that I'm going to add is already present in my row, column or grid or not. So let's check that. So if guys, I'm not writing in one line, I'm writing in 3 different lines so that you are more clear. So rows I and let's create the mask. How we'll create? 1 left shift nums times. This will go to that particular bit and check if it is on and or off. Is 0. If it is off, in that case only we need to work. Similarly, I'll check the same for my columns and grid. So for calls j and for grid ij, but not exactly ij. Let me tell you why. See, when I am here, this grid is not for this particular. We'll get this grid at this index, this grid at this index, this grid at this index. Similarly, here, total 9 grids. 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 grids. Okay. So, what do we need to check? If I want to get at this index, if I am anywhere in this grid, and I do I by 3 and j by 3. I is here till here. If it can be from 0 to 3, if I do that, I'll get 0. J could be from 0 to 3. I could be from 0 to 3. If I divide them by 3, I'll always get 0. Okay. So by this, we can get the particular grid. So we'll divide it by 3. This will do the work. If all of this is true, then we need to simply first put at array ij the number. Let's put that. Then what do we need to do? We need to make this call, this recursive call. And then remove the number. Put 0 again when we backtrack. Okay. Now what, guys? Now I'll have to off the bits. Okay. I have on them, but when I'm backtracking, I need to off them. First here I'll on them so that in another recursion, when I do the recursive call, those bits are on, and then I'll off them. So let's first on them. So rows I XOR equals 1 left shift nums time. We'll do the XOR operation to toggle. This is toggle thing that we used to do. Okay, we are toggling. You guys please watch the previous videos because I am using the concepts that were taught in those. So similarly for calls also, I'll on those bits. For grid also, grid I by 3, j by 3. Okay, by doing this I am toggling those bits. They were initially off, now they would be on. How do we know that they were off? We have already checked in if condition. If all of this is true, I'll again toggle them and off them. Okay, first on them, then off them. Instead of XOR, you could do its complement, and for owning, you could just simply or use the or operator here and operator and its complement. But why to do so much when we could simply toggle them by using XOR? Okay. Now what about the base case? Let's write it here. So if my I is equal to array dot length, simply display the array. I have already written display function, so we'll call it and return. So why I am doing this array dot length? Let me show you. When I am here at the end, then I am at my I is array dot length minus 1. When I shift to here at array dot length, that means I have already filled all the Sudoku and I need to print my answer. Okay, let's run the code. Check for the errors in line 28. Okay, here forgot to put AND operators. Okay. Yeah, this is the output that we needed and we have got this. Let's submit the code. I hope guys the question was clear to you. The code was also clear. So please like, share and comment and subscribe to Pep Coding. All the test cases are passed. See 7 out of 7. So thank you for watching.